Hello, in this video we're looking at hypothesis testing as it relates to correlation coefficients. So a little thought experiment. Consider that we've taken two sets of 25 measurements and we've calculated a product moment correlation coefficient of negative 0.394 between the measurements. We would probably say, if we were asked subjectively, that this feels like a weak to moderate correlation, but how can we approach it more objectively? Well, we use what is called a table of critical values of correlation coefficient. So this is what a critical value of correlation coefficient table looks like. It has 5 significance levels: 0.10, 0.05, 0.025, 0.01, and 0.005. And then down the right hand side, lots of sample levels. We were talking about a sample level of 25 measurements a minute ago. So this table concerns tests of the hypothesis that a population correlation coefficient rho is 0. The values in the table are the minimum value which need to be reached by a sample correlation coefficient in order to be significant at the level shown on a one-tailed test. And we use it the same way whether we're dealing with positive or negative correlation. It's just we put a minus sign in front of each of those product moment coefficients. So coming back to our thought experiment, 25 measurements with a correlation coefficient of negative 0.394. So as I say, subjectively, we'd be feeling it's maybe weak to moderate negative correlation. So that would be a one-tailed test where we're asserting, in this case, a negative correlation. Our null hypothesis would be that H0 is that rho equals 0. So that's always our null hypothesis, that there is no correlation at all. And in this case, we're investigating the alternative hypothesis that H1 has rho as less than 0, i.e. there is negative correlation. So up till now, we've been used to using R for our correlation coefficient. When we're doing hypothesis testing, we use rho, which is the Greek letter for R. So let's use a significance level of 5% to investigate our correlation coefficient of negative 0.394. So that's the second column, the 0.05 column. We want the rho, which has a sample level of 25. And then reading across, our critical value is 0.3365. So what that means in general, if we were doing positive correlation and we got a value which was greater than 0.3365, then that would indicate positive correlation. Similarly, if we're doing negative correlation, we get a value close to -1, then a negative 0.3365, that would imply negative correlation. So we got a value measurement of negative 0.394, and in magnitude that is greater than the size of negative 0.3365, i.e. it is closer to -1, and that means that we have evidence of correlation. Sometimes it might be that we're just looking at a change or something that is different from what might be suggested. So that would be a two-tailed test rather than a one-tailed test. We're just asserting there is correlation. We don't mind what type it is. The null hypothesis is still H0 is rho equals 0, but our alternative hypothesis this time is H1 rho is not 0. So in our example, we're considering a correlation coefficient of 0.406 for a sample level of 19. Again, we have a significance level of 5%, and we're looking to see if there is evidence of correlation. So we've already stated our hypotheses: H0 rho equals 0, H1 rho is not 0. But because it's a two-tailed test rather than a one-tailed test, we're going to halve our significance level. So rather than being 0.05, because it's 5%, our significance level will be 0.025. So we're going to use the third column in the table with a significance level of 0.025. Our sample level is 19, and the table says 0.4555. So our critical value from the table is 0.4555, and then we compare the value we got. We've got 0.406, that is obviously smaller than 0.4555. So that means that there's nothing to suggest our null hypothesis isn't correct. So we accept H0 and we say there is no evidence of correlation. And notice that our correlation coefficient is larger in magnitude than previously when we got negative 0.394. And this time we're saying there's no evidence, and before we were saying there is evidence, but that's because we have a different sample level.